Okay, we continue on the concept for sufficient statistic. So again, this one is on the Fisher-Neyman factorization theorem. Okay, so Fisher-Neyman factorization theorem. So it's the same thing. Okay, so you have x1, s2, sn. You have a PDF, and then you want to show that your t, which is a function, okay, of your random sample, your observation x1, s2, sn, is a sufficient statistic. If we can write down our joint probability function, you can split into two parts. The first part, you have contain parameter, theta, okay. And then the other part, you have your h, x1, x2, sn. It does not depend upon data. Okay. So once you can write this joint probability function, ataupun joint PDF into two parts, so that means your gt theta ni, kemudian t ni is your sufficient statistic. Okay. Okay, sufficient statistic here, okay, again, one-to-one function. For example, let's say if you have x bar, okay, so in your derivation, let's say you find that x bar is a sufficient statistic, okay. So the same thing, if you want to show that x bar, you can write in terms of summation si over n. So if you get summation si over n, so your summation si is also a sufficient statistic. Sebab kamu yang n ni is a constant. For example, you have k theta head, okay, 2x bar ataupun x bar plus 2. Still, this one is a sufficient statistic for theta. Okay. Okay, we already compute this one. Okay, that means you set up your joint probability function. Okay, make sure again, you write your simplified form is correct. So you have theta to the power n, product si to the power theta minus 1. Okay. So kita dah simplify. So this part, you have gt theta. Okay. So the other part, 1 over s1, s2, sn ni, kamu punya hx, which is does not depend upon theta. So bila kita nak kenal pasti which one is your sufficient statistic, kita tengok yang ada x1, s2, sn ni. Okay. So that's mean in this case, your t ataupun your theta t kat sini, s1, s2, sn ni, your product is a sufficient statistic for theta. Sebab kita tulis dalam bentuk notation dia adalah G, P, theta. Okay, maksudnya kamu punya T tu, kamu punya function of x1, s2, sn, and at the same time, we have parameter theta. Okay. Okay. Okay, so the same thing we already write down, fx theta, theta over to the power x to the power theta plus 1. Okay, when you expand the formula, okay, this one, theta over x to the power theta plus 1. So you will have theta over x theta plus 1, again theta over x2 theta plus 1, up to theta over sn theta plus 1. Okay, nak simplify form kan, ini kita ada theta, 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 kita darab. So kita ada theta to the power n, bukannya n theta. N theta bila kita ada theta plus theta plus theta, itu baru n theta. Okay, so this one, theta to the power n. You have your product xi to the power theta plus 1. Since your hx again does not depend upon theta. Kamu split kan lah, kamu ada theta n, this one. Ada family. Cuma kat sini, okay. Ini Iqbal buat tadi note ya Iqbal, this one should be t 1 over product xi. Okay, bukannya product xi. Dia tengok kedudukan dia. So that means 1 over product xi is your sufficient statistic. And this is your hx. Okay, so I don't tulis lah. Okay. So that is the part A, and then part B pun the same thing, part B pun sama. Okay, kamu expand. So kamu tengok kat sini, kamu split kan. So this one does not depend upon theta. Yang nanti kat theta sini je. So kita ambil terus. Kita tak perlu letak negatif summation si square terus. Dia T kamu summation si square. Okay, is your sufficient statistic. So again, dalam satu function, for certain probability function, for example normal distribution lah, you can have more than one sufficient statistic. Maksudnya katakan T, kalau kita expand, kita ada summation SI. Satu lagi kita ada mungkinlah summation SI square. So both are sufficient statistic. Okay, bergantung pada how you derive lah. Biasanya itu kalau normal distribution is depends. Depends pada probability function. Okay, next kita. Okay, saya nak tunjuk this one, exercise 2.4 ni. Ni tak ada yang cuba kan? Exercise 2.4, kalau ada yang cuba boleh share juga dalam Telegram. Okay.
Doktor, yang 2.3 tu, kiranya saya tak perlu 1/HX. Saya terus ambil HX terus dah boleh dah.
Okey, kamu tak ambil HX tau. Kamu, ini kan, kamu buat tadi kan? Ini kan? HX kamu tu, yang ini, 1 over product SI tu, kamu punya ni. Okey, tapi T kamu tu yang ada parameter ini. Ini.
Oh.
HX kamu. Yang produk 1 over S ni adalah sufficient statistic. Kita tengok yang ada theta kan, kita G, T, theta. Jadi kamu punya HX kan? HX memang kita nak does not depend upon theta. Memang tak ada theta kat situ. Yang ada theta sini je. Okay, tapi sebab kedudukan dia 1 over lah kan. So kita ambil 1 over lah. Kecuali lah kalau memang dia kat atas. Kalau dia kat atas terus je lah produk XI.
Terus ambil H dah cukup ingatkan 1 over H sebab kita bahagikan.
Tak, H tu ini. H kamu tak ambil apa-apa. Cuma H tu kita notify kan. Dia tak depend pada theta. Dan kita tengok T tu. Apa dia punya T dia? Okay.
Nampak.
Yang lain kalau let's say ada problem, tak faham. Sebab saya rasa kamu tak faham sebenarnya. Bukan tak revise ke apa ke. Tak faham. Lebih kepada tak faham. Maksud saya, okay, every time saya upload saya punya video, okay, tengok balik. Kadang-kadang bentuk soalan yang sama juga saya ambil. Saya perasan tu mesti ada satu soalan yang hampir semua tidak dapat menjawab lah. Okay. Kita tengok balik lah. Okay. Again, so this one you have x1 x2 xn denote a random sample from a distribution that is normal. Okay, kamu tengok theta sigma square. Saya dah cakap kat sini sigma square is known. Okay, sigma square is known. So yang kamu nak estimate is your theta. Okay, theta that's mean kamu punya mean ni, which is mu equals to theta. So that's mean this is your unknown parameter. Yeah, unknown parameter lah. Okay, show that your x bar, which is summation xi over n, is a sufficient statistic for theta. Okay, so again, this one is a normal distribution. Okay, normal distribution. Okay, you just write down. Okay, first kita ada video. So this one you have fx theta. Okay. Kita pilih fx theta pun okey lah sebab kita punya unknown parameter is just theta. Sigma square tu is known. Okay. Once sigma square is known tu kamu boleh treat benda tu as a constant actually. Okay. So again, you just write your PDF for normal distribution. So sigma square root 2 pi ataupun square root 2 pi sigma square. So dia sama exponential negative x minus theta square over 2 sigma square. So this one. Okay. So now you have product I equals to 1 up to n fi theta. Okay, so you have 1 over sigma square root 2 pi exponential, dia akan jadi negatif jumlah xi tolak theta square over 2 sigma square. Okay, sigma square kamu ni tak ada n, bila keluarkan tu tak ada sigma square n. Dia ada negatif summation kat atas tu xi minus theta square. Okay, so now you want to show that x bar is a sufficient statistic for theta. So dalam kau punya expansion ni tak ada nilai x bar, kamu ada summation xi minus theta square. So macam mana kita nak masukkan nilai x bar dalam tu? Sebab kita nak show that. Maksudnya kamu nak prove mesti ada x bar. Kalau dia tak cakap, kalau dia cakap find the sufficient statistic for theta. So it's okay. Tak kisah. Kamu boleh teruskan selesai macam biasa. Okay, since this one you want to show that x bar is a sufficient statistic for theta. Okay, cuba fahamkan dia punya soalan eh. Show that maksudnya kita dah bagi hint. Mesti dapat x bar. Okay, so that's why you have to expand this one. Katakan saya ambil okay, summation xi minus theta square. Okay, kita masukkan term x bar dalam tu. So you will have x bar minus x bar plus balik x bar minus theta square. Okay, so now you split. you have xi minus x bar, kita square kat sini. And then, so you have 2 summation xi minus x bar minus theta. Okay, satu lagi kita ambil. Okay, ini ada summation ya. So you have n x bar minus theta square. Okay, faham tak daripada step ke sini, dapat sini ni. Macam mana saya masukkan? So kamu gantikan x bar plus x bar. So expand lah macam a plus b square. So you have a square plus b square plus 2ab. So the same thing. Okay, so you will have summation si minus x bar square plus 2 summation si minus x bar minus theta plus n x bar minus theta square. Okay? Okay? Okay, now kita cuba simplify kan. Yeah, so that one. So sekarang ni kita tengok yang ni. Okay, 2 summation si minus x bar minus theta. Okay, this one. X bar minus theta. Okay, kalau this one, 2 summation si minus x bar minus theta. Benda ni dia akan jadi 0. Macam mana dia boleh jadi 0?
X bar tolak theta 0.
Theta. X bar tolak theta 0 kenapa?
Theta sama dengan X bar.
Tak, kita tak gantikan lagi. Iqbal, belum lagi. Sebab kita nak tunjukkan ni actually. Cuba kamu play around dengan this one dulu. Xi minus x bar. Cuba simplify kan. Dia jadi apa?
Apa?
Cuba kamu ni kan. Katakan x bar tu kamu tukar lah. You have x bar tu tukarlah summation si over n.
Oh, yes.
Kan?
Berasa. Oh, so 2 and I.
Kita makan dapat apa guys tu?
Equals to 2 and I 1.
Okay, bila kamu dah show that benda tu, yang benda ni, bahagian term ni, okay, summation si minus x bar minus theta tu become 0. So, yang bahagian ni dah tinggal 0. Yang tinggal yang itu je. Okay, ada idea tak macam mana yang this term boleh menjadi 0?
Saya dah buat dah. Tapi tak mesti belum ada idea lagi, doktor.
Yang lain. Wicked ada idea tak Wicked?
Wicked, help me please. I can only go so far.
Okay, cuba kamu expandkan dulu.
Okay, saya expand.
Ataupun cuba cari Google.
Sekejap.
Okay. So it's the same thing lah. Let's say katakan this one. Okay. Sebab ini kita punya ni, kita ada I equals to 1 up to n. Okay. So kalau this one, let's say, okay. So katakan kita buka dia punya, so kita tengok yang bahagian ni je. Macam I minus x bar This one So kamu tengok bahagian ni, summation xi minus x bar. So kalau sama tak kalau satu lagi? Summation xi minus n x bar.
Yes. Ya Allah, patutlah saya tak dapat.
Okay, so now you have n summation xi over n. Okay, so n cancel out, so you will have summation xi minus summation xi. So that's why that term goes to 0. Okay?
Kena keluarkan lah ni.
Okay, so itu dia punya alternatif lah So that's mean kita nak selesaikan, so this term tu akan jadi 0. Okay, so you will have summation xi minus x bar tu. It's the same thing if you write summation xi minus n x bar. So x bar tu you change summation xi over n, so n cancel out, you have summation xi. So that's why this term will become 0. Okay, once this term will become 0, okay, kamu gantikan balik. Kan? Okay, nanti saya tulis balik. So that's mean, okay, you have this one right? Okay. Okay, exponential. So that's mean you will have kita tulis balik that one. So that's mean ni sambung balik sigma square root 2 pi, and you will have exponential negative summation xi minus x bar square over 2 sigma square. Okay. Satu lagi exponential negative n x bar minus theta square over 2 sigma square. Okay, kat sini saya go back sini. Okay, kamu gantikan ini, term ni dah jadi. Okay, term ni dah jadi 0. Okay, this one become 0. So yang kamu ambil this term dengan ni je. So gantikan balik kat sini. So exponential depan sama, exponential negative summation xi minus x plus square over 2 sigma square. Satu lagi exponential negative n x bar minus theta square over 2 sigma square. Okay, so saya sambung sini. Okay, baru kita ada term x bar. Okay, so now kita splitkan into 2 parts. So the first part either contain parameter theta ataupun yang second part tu does not contain parameter theta. Yang kamu concern adalah theta, bukannya sigma ataupun sigma square. Okay, yang ada theta ini je. Ni, this one. Ni. So that's mean G T theta kamu, you will have exponential negative n x bar minus theta square over 2 sigma square. Okay. Kamu punya hx yang tu, yang tak ada theta tu. So 1 over sigma square root 2 pi to the power n exponential negative summation xi minus x bar square over 2 sigma square. Okay, so that means since your hx does not depend upon parameter theta, so kita punya gt theta adalah this one. So your t x equals to x bar is a sufficient statistic. Okay, so ini baru kita ada term x bar ni. Okay, so itu case-nya, case for normal distribution. Okay, I go back. Case for normal distribution when your mu is equals to theta, so unknown parameter, but your case variance sigma square is known. Okay, so show that your x bar is a sufficient statistic. Okay, so since we don't have the term x bar, so you must include the term x bar in your expansion. So you have summation xi minus x bar plus x bar minus theta square. Okay, so kita splitkan, buat persamaan kuadratik macam biasa. Okay, cuma this term dia akan jadi 0 lah. Ya? Dia akan jadi 0 because this one. Okay. And then gantikan balik. So gantikan balik. So that's mean split kan. Which one is your HX, which one is your GT data. So ambil T saja. So kamu ada dalam case ni, T is your X bar. So that's why your X bar is a sufficient statistic. Okay. Okay, ada apa-apa soalan? Boleh ke?
Kakak ni belum ada lagi.
Boleh follow tak saya punya ni? Boleh eh?
Boleh?
Okay, satu lagi. The same question. Okay, the same question eh. So now katakan saya nak tunjukkan the same distribution. The same thing. Normal theta sigma square. Okay, kita. Same one. Normal. Okay, normal theta sigma square. Okay. So now saya nak katakan saya nak tunjukkan show that T equals to summation xi is a sufficient statistic for theta. Okay. So the same thing. Okay. So kita ambil balik dia punya join PDF. Okay. So kamu dah ada tadi 1 over sigma square root 2 pi to power n exponential negative xi minus theta square over 2 sigma square. Okay. So sekarang ni saya nak term dia summation xi adalah kamu punya tu. Okay. Silap. Ya, saya tengah buat slide itu lagi. Okay, so you have 1 over sigma square root 2 pi to the power n exponential negative summation xi minus theta square over 2 sigma square. Okay. So now you have 1 over sigma square root 2 pi over n. Kita expandkan this one. So exponential negative summation xi square plus 2 theta summation xi plus ke mana? Okay, plus theta square, so minus n theta square. So this one semua over 2 sigma square. Okay, kamu expand kan? Okay, kaedah kuadratik lah ya. So kamu ada summation xi square plus 2 theta summation xi. Okay, ini theta je, so plus minus n theta square. So ini kita ada minus theta square, so plus theta square, so minus ke depan. So minus n theta square. Okay. So now kita susun 1 over sigma square root 2 pi to the power n. We have exponential negative summation xi square over 2 sigma square. Okay. And the rest tu ada. And the rest kita ada theta. And then we have exponential. Okay, 2 theta, 2 ni saya cancelkan. So theta over sigma square summation xi. And then minus n theta square over 2 sigma square. Okay. So ini kamu punya first part which is your hx does not depend upon theta. So yang ni kamu punya g t theta. Okay, kita ada theta ini cancel out. Theta over sigma square summation xi minus n theta square over 2 sigma square. So both ada theta. So yang ada x so ini saja. So that's mean your t equals to summation xi is a sufficient statistic. Okay, statistic. So next, itu yang saya cakap tu, dia kalau sufficient statistic ni is not unique. Kita akan tengok juga lah nanti another section lagi. Where bila kita ada hanya satu je lah sufficient statistic, that's mean kita panggil unique sufficient statistic, and dia akan jadi unique minimum variance unbiased estimator juga. Okay. So this one, when you have case mu is theta is unknown, your mean is unknown, case variance sigma square is known, it can be two lah, sama ada you can have x bar is also a sufficient statistic ataupun t equal to summation xi is also sufficient statistic. Kalau let's say soalan dia find the sufficient statistic, kamu boleh bagi mana-mana satu, sama ada x bar ataupun yang tadi. Okay, kalau dia cakap show that, maksudnya kena tunjuklah sampai kamu dapat nilai x bar tu adalah sufficient statistic. Okay. Okay. So again lah, this one, sebab kita ada for normal distribution, okay, normal kamu ada, biasa kita ada mu sigma square. So dia akan ada case mu is known, sigma square is unknown. Ataupun mu is unknown, sigma square is known. Ataupun both mu and sigma square are unknown. Dia ada tiga benda. Tiga case lah yang kita boleh considerkan dan dapatkan dia punya sufficient statistic. Yang saya tunjuk ni hanya case satu je lah. Case sigma is known. Katakan saya tukar soalan. Mu is known, sigma square tu saya gantikan theta. Lain lah dia punya tu. So itulah yang mana satu dia punya sufficient statistic. Okay, so it can be anything.